This models the failure point of standard AI integrations. A linear pipeline eventually collapses because it pushes data in only one direction. Developers configure these wrappers to fire prompts out to external endpoints. The system executes the query, but it possesses no mechanical way to verify if the output actually reached its final destination. When an integration fires blindly, it immediately loses its context window. The logic model forgets the interaction the millisecond the text generation completes. Engineers are forced into a tedious position. They must build manual state tracking systems and rely on constant human verification to confirm live outputs. The critical architectural component missing from these developer stacks is a persistent memory layer. Production-ready autonomy requires a bidirectional data pipeline rather than a one-way query. The engine must send a command and receive absolute confirmation of the result. Without a closed feedback loop, it remains a brittle text generator. To build a self-sustaining autonomous engine, the data must return to its source. This maps the three layers of a closed-loop engine: an input orchestration cluster, a multi-platform routing layer, and a state management confirmation layer. A visual barrier physically isolates the transient AI logic from your persistent state, which acts as the absolute source of truth. You can construct this entire enterprise-grade engine from scratch in under 2 hours. Deploying this decoupled architecture from scratch permanently removes any need for tedious human intervention during complex, large-scale, cross-platform data publishing. We start at the foundation. The persistent memory database serves as the command center for the entire workflow. A Notion database row acts as the trigger. Changing a topic status to approved emits a payload. This mutation instantly fires a webhook to the orchestration layer, delivering the raw topic and persistent chat context necessary for the language model. Configuring the database to trigger the workflow automatically eliminates the risk of manual copy-paste errors. True autonomy starts by treating a database status update as an executable backend command. Power shifts entirely from human input to system state. The data payload now enters the core orchestration cluster. Using N8N, the orchestration engine intercepts the webhook and passes the raw database payload directly into the Claude 3.5 Sonnet API. The payload hits an event node and divides. Path A synthesizes the raw data into a strict 280-character payload optimized for X. Simultaneously, Path B reformats the same data into a complex long-form payload optimized for LinkedIn's formatting roles. The core orchestration layer performs a powerful structural mutation, mapping a single raw input into simultaneous platform-native states. With the text finalized, the two tailored payloads exit the N8N logic layer and move into make.com, the multi-channel distribution router. We must structurally decouple the act of routing from the act of logic generation to keep the engine stable. External distribution introduces severe challenges. First, the engine must manage highly disparate authentication protocols required by different external APIs. Second, it must navigate the strict, conflicting rate limits imposed by those platforms. This animated diagram demonstrates router path A pushing the short-form payload directly to the X API for immediate publishing. Meanwhile, router path B connects to LinkedIn, embedding a peak hour timestamp variable, holding the payload until the optimal moment. This distinct layer operates as an asynchronous traffic controller for the entire architecture. Implementing a dedicated routing pipeline structurally insulates your core AI logic from the fragility of third-party platform bottlenecks. The final mechanism is the confirmation loop. This exact step separates a basic script from a true autonomous agent. The loop triggers only when the routing layer receives verified HTTP 200 OK responses from both external APIs. Two confirmation signals originate at the endpoints, bypass the orchestration layer, and hit the persistent database directly. They update the Notion status from approved to published and automatically insert the live URL strings into the row. This callback ensures the entire engine is strictly idempotent. The system tracks its complete lifecycle and updates its own state without requiring human oversight. This blueprint-style rendering illustrates the complete data journey. A state-driven trigger launches parallel orchestration, pushes through routed distribution, and concludes with a self-updating callback. You can build this complex orchestration layer as a single developer in under 120 minutes. Once you close the loop, the engine scales infinitely. A single idea approved in a database automatically commands a multi-platform cascade. Stop relying on manual status tracking. Start engineering your own closed-loop routing systems today. The difference between an AI tool and an autonomous agent is memory and consequence. Build consequence into your next architecture.